Hello students, in today's class we will discuss about the third unit which talks about the transport layer. Already we have discussed a little bit of transport layer when we are discussing about the applications, networking applications. So the textbook that we are going to follow is Computer Networking, a Top-Down Approach, 9th edition by Jim Couros. So the agenda for this unit is we are going to discuss about the transport layer principles. Okay, so first let us discuss about what is multiplexing, demultiplexing, what is reliable data transfer, flow control, congestion control, and then very specifically we will be discussing about the user datagram protocol and the transmission control protocol. And when we talk about the transport layer, so the roadmap is, this is how the roadmap is. First, let us discuss about the transport layer services, and then we are going to discuss about multiplexing, demultiplexing, and then we will discuss about the UDP, user datagram protocol. Then we will discuss about the transmission control protocol. In transmission control protocol, very specifically, we will talk about flow control and congestion control. And what is the main purpose of a transport layer is? So maybe in the client side, in your mobile phone, you will be using a lot of networking application. So you will have a streaming video applications, you will have a chat application, you will have a banking application, you will have a e-commerce application. So exactly the reply comes to that application. Every time you use a banking application, so all the response comes from the banking server to the banking application. So how is this possible? The client process exactly communicates to the server process. So how is this process possible is because of this transport layer. So it provides a logical communication between the application process running on different hosts. So transport layer is mainly it concern about connecting your processes or connecting your the application of the client to that of the application of the server, right? And usually in the sender side, the application messages or it's just splitted into small segments, and then it is just transferred to the network layer. Similarly, in the receiver side, it is reassembled. Okay, so the data is reassembled and it is handed over to the application layer. So there are two well-known protocols. One is TCP, Transmission Control Protocol, and UDP, the User Datagram Protocol. So now what is actually the transport layer? So in order to understand what is actually a transport layer, so say I have a house, all right? So you have a house and you have a father and a mother, okay? And I have kid one, right? And I have kid two, right? So that it's a small house. So this is say house one. And again, I have another house, all right? So say this is house two. Here again, I have father, then a mother, then a kid 2, 1, say 2, 1, and kid 2, 2. Okay. Now, say kid 2, 1 wants to post a small letter. Okay. So maybe a happy birthday card to kid 1 in house 1. So what this kid 2, 1 says is he just framed the message. Okay. The happy birthday message. All right. So this is called the application layer packet. Okay, so he just draw some pictures and he just frame and he put it inside a postal card. Okay, so usually we'll put it inside a cover, an envelope cover. So what is the first thing that you do is in the envelope cover, okay, what is the first thing you will write is he writes the name of the kid. So the receiver, the sender writes the name of the receiver. Say this is K1, all right. So K1 and he belongs to maybe the street name, the door number, and he belongs to house 1. Okay, so this is this is the very important structure of a to address. Okay, so he will write the kid name and then the house name. So the kid name can be thought like of a port number. Okay, so usually we discuss the concept of port number when we are discussing the application layer. So every process, every application, for example, you want a YouTube video, you want to see YouTube videos, you open a YouTube application that is assigned with a port number. So house 1 is the IP address. Okay, so that can be called as an IP address. And then we have something called a from address. Then we have something called a from address. So in the from also you will say that from where this message is, kid 2 1, and then from the house 2. So this is the port number of the receiver or port number of the sender, and this is the IP address of the sender. All right. So the IP address and the port number forms a very, very important role. So once this envelope goes through the postal department, reaches this house, okay, so the postman exactly deliver the message to the house. And who is the receiver? K1. So exactly to K1, he delivers it. So this is called the port number and the IP address. Together, this port number and IP address, they are called as the sockets. We'll call them as a sockets. Okay, so this is the concept behind the transport layer and the network layer protocols. Okay, so this is how the transport layer protocol and the network layer protocol helps with each other. So transport layer, it is a communication between the process. It relies on the network layer services, and network layer is a communication between the host. Okay, two entities. Maybe it connects the client and a server. And transport layer connects the application that is running in the client and the application that is running in the server. So this animation shows how a message travels from the application layer of a sender to the application layer of the receiver. So as it starts from the application layer, it is passed to the transport layer in the sender side. So when it comes to the transport layer in the sender side, the transport layer adds some header fields like port numbers, sender port number, receiver port number. Okay, so maybe in the coming classes we will discuss. It can contain some checksum value to check the error. It has some sequence number, some acknowledgement number. So in general, in the transport layer, the port numbers are added. And then when it comes to the network layer, again, okay, so it adds the IP. Okay, so once that is done, it goes through a massive internet and it reaches, so this is an internet and it reaches the receiver side. So when it comes to the receiver side, it has to initially come to um, it will come to the network layer, okay, and the network layer will check whether this is for that particular user, and then the port numbers, okay, so it will fetch the port number from the header value and exactly to the application, okay, intended application, the message is delivered. Okay, so the process that is happening in the sender side, usually we'll call it as a process of multiplexing, and the process that happens in the receiver side, we'll call it as a process of demultiplexing. Okay, so there are two main protocols. One is the transmission control protocol. So the transmission control protocol makes sure that there is a reliable delivery, message delivery by introducing something called a sequence number. For every sequence number, it receives an acknowledgement. There is also a congestion control to maintain the packet delivery, or to manage the packet delivery in the network perspective, flow control to manage the packet delivery in the end system perspective. There is a connection setup. Okay, so there is a handshaking process that takes place before the transmission control protocol, before the application messages are transferred. There is a handshaking protocol. The client makes sure that the server is available. The server makes sure that the client is available, and then only the data transfer takes place. But the user datagram protocol is something which is different. It does not have all these process like reliable data transfer, congestion control, flow control, connection setup, but it makes sure that your packet is delivered to the best of its effort. Okay, so that's the difference between TCP and UDP. This, it does not guarantee any bandwidth guarantees, delay guarantees, and all these services are not ensured by the transport layer. Now moving on to the next concept, multiplexing and demultiplexing. So what does a multiplexing does? Okay, so multiplexing is maybe many applications. That can be many applications running on a single entity. So say this is a server. So the server may have process 1 and process 2. Okay, so now when it comes to the transport layer, it has to be multiplexed. Okay, it has to be embedded with a single IP address. See, P1 is also a process that is going to come out of the server. P2 is also a process that has to come out of the server. So now the transport layer makes sure that these two applications are multiplexed and it passes to a single networking layer where the IP address is embedded. Okay, and then it has to reach P3 and P4. So the multiplexing handles data from multiple sockets at the transport layer. Okay, and then demultiplexing this header information is received. Okay, so now when the data is received here to the transport layer, so the transport layer exactly identify, oh, this is a message with the port numbers. It will identify this is a message that I should give it for this application. This is a message that I should give it for this application. So when you talk about multiplexing and demultiplexing analogy, we can have it, say, imagine this is a HTTP server and there are two clients, and this client handles application Skype and an application Netflix. Similarly, this handles an application Chrome, a Chrome application. Okay, and here is an Apache server. Okay, so now the HTTP message is embedded. Okay, and when it comes to the transport layer, the port number is added. When it comes to the IP layer, network layer, the IP address is added, and then the message passes to the client side. When it comes to the client side, exactly it goes to the Chrome. Okay, exactly it goes to Chrome. So how is this possible? How is this possible? How is this message not transferred to the Skype? How is this message exactly going to the Chrome? This is because of the transport layer which manages the message by the port number. So every message is given a port number. So exactly when a message comes with that port number, it identifies, oh, this is a message that is coming with 80. So 80 is a well-known port number for a HTTP application. So I should transfer this to a HTTP application. So this data management is done by means of a port number. So demultiplexing, as we discussed, as the data comes, it is just splitted. Okay, so whether based on the port number, it's 80, I should give it to the Chrome. Okay, if it is a Netflix port number, I should give it to Netflix. If it's Skype. So this can be viewed like an analogy of your highway roads, where you say, if suppose I want to take the Chennai, I should go this way. If suppose I want to go to Bangalore, I should go this way, right? So how do you know that? So Chennai, the name boards indicates that you have to go by this way, and Bangalore indicates that you have to go by this way, right? So similarly, when your data comes to the transport layer exactly identifies to which uh, application the message has to go, and it reroutes. The same case of multiplexing. So many transport layer. Okay, so this is a Netflix application, this is a Skype application, this is a Chrome application. So all these application comes with the different port numbers. It is given to the network layer. So the network layer adds an IP. Say IP of your computer is 8.8.8.8. So it says Chrome 8.8.8.8. So Skype, let it 8.8.8.8. So this is Netflix 8.8.8.8. But the port number is different, 80. So maybe Skype port number, maybe I say this is 1000 and Netflix is 1001, right? So this is called the multiplexing. So many applications are mapped to a single IP address. So that function, okay, combining all these applications together and giving to the network layer is done by the transport layer, and that process is called as the multiplexing. So you see that many traffics are coming from the sub roads and it's coming to the main roads. Okay, so all this is the main roads, they are coming to the main roads. So this can be talked as a multiplexing. Okay, so host receives the IP datagram. Each datagram has a source IP address, destination IP address, and each datagram carries one transport layer segment, and each segment has a source and the destination port number. So this combination, IP address and the port number combinations, are helpful for creating this sockets. Okay, and the sockets, with the help of a socket, exactly it is delivered to the application.